Hello everyone. Now let's take a look at question 4 from November 2025, Maths paper 1. So they say that f of x is equals to log x base 1, right? So this is 1 over 3, not 1, sorry. Log x base 1 over 3 is drawn below. Point A here is the x-intercept and f is 3 to t. So without even looking at the question, we know that this is actually an inverse, or rather, let me say the inverse of this graph would be what we call an exponential graph that looks like this, guys, a decreasing exponential graph, right? That has a y-intercept here at 1, right? So the y-intercept of this exponential graph is at 1, and the equation of this exponential graph would be y equals to 1 over 3 to the power x. You might ask yourself, where do I get this from? You see where we are given the logarithmic function. Just take this the way it is, this 1 over 3 to the power x. You see, it looks like 1 over 3 to the power x. 1 over 3 to the power x equated to y, it will give you the equation of what? Of the inverse, right? So y equals to 1 over 3 to the power x. It's the inverse function of this, right? And as you can see that the inverse function has a y-intercept at 1. On the original graph, this one, or on the inverse, this one would be an x-intercept. We would switch them. So we already know that the coordinates here would be 1 is to 0. Right, so here the coordinates were 0 is to 1. So on the inverse graph, we switch them. It gives us 1 is to 0. We switch the x and the y, right? Write down the coordinates of A. We already answered that question. Calculate the value of t, 4.1. Let's do 4.1. Yeah, let me use black. 4.1, or let me use a different color instead of black. Let's try blue. I can't have only blue. That's blue. Let's try purple. 4.1. Calculate the value of t, right? So t is equals to f of what? F of 3, which is going to be equals to log 3 base 1 over 3. Let's put that in our calculator, see how much we get. Log that and that. That's -1. So this is -1. So the coordinates here of t are sorry, not the coordinates of t. Those coordinates are 3 is to -1, right? Let's move on to 4.2. Write down the coordinates of A. We already figured that one out. 1 is to 0. 4.3, they say we should determine the equation of the inverse. We already figured that one out. Y equals to 1 over 3 to the power x. 4.4, they say we should write down the equation of the asymptote of the inverse, the asymptote of this graph. Remember, this is plus q, right? So where q is the asymptote, but on this graph, there's no q value, right? So it's the same as plus 0. So our asymptote is y equals to 0, right? But then another way to find it, as you can see that this graph, it is approaching the x-axis, but it never touches the x-axis. What is the equation of the x-axis? The equation of the x-axis is y equals to 0. Because of the x-axis, on the x-axis, y is 0, right? So y is 0 is the asymptote. Let's move on to 4.5. 4.5, they're actually asking us to draw the graph. We have already done that. Let's draw it again here. I'm just going to use red to draw it. Approaching the asymptote, as you can see. Then this is the y-axis, this is the x-axis. The coordinates here are 1. Then we can call this y equals to 0 as well, just to show that it's the asymptote, right? 4.6, the graph of h is obtained when this, the inverse, is translated 5 units to the right. So remember, the inverse is y equals to or y equals to, or let's call it f to the power -1 of x is equals to 1 over 3 to the power x, right? This is the graph. So if I move this graph 5 units to the right, my graph would be h at x, right, would be h at x. So h at x would be 1 over 3 to the power x minus 5, because when I move a graph to the right, I must minus 5 from x, right? So when I must minus 5 from x, I moved it 5 units to the right, I minus 5 from x. So that would be the equation of h of x, right? So let's read the question. Determine the values of y. So usually they are in the exams, they would usually ask you to find the values of x where y is that or whatever, right? But in this case, they want the values of y provided that x is bigger than 4. So first things first, let's find the critical value where x is equals to 4, right? That would be our critical point. So h at 4 would be equals to 1 over 3 to the power 4 minus 1. Let's put that in our calculator and see how much we get. 1 over 3 to the power 4. Is it 4 minus 5? Not 1, sorry. That's 3, no? That's 3. This is 5 here. Sorry, 5. 4 minus 5, that's 3. We saw, right? So this is the x, the y value where x is 4, right? So this graph h at x, right, would also be a graph that looks like this, right? This is going to be similar to the graph of let's not do that. It's going to be similar to the exponential graph, right? So let's suppose that here it's 4, right? The x value here it's 4. We know that when x is 4, y is 3, right? So now they say that when x is bigger than 4, how would be the y value? How would the y value be, right? So as you can see, the x values where x is bigger than 4, they're from here moving to the right. So as I move to the right, the x values are bigger than 4. They want me to tell them how are the y values at that point. In this portion of the graph, we need to describe the y values. The y values, as you can see, they are becoming less than 3. So this is 3, right? They are going below 3. The y values are going below 3. They are approaching 0. They are approaching 0. The y values are approaching 0, but they never touch 0 because at 0, it's an asymptote, right? So as you can see now, we can describe them and say that, okay, the y values are bigger than 0 but less than 3. So they're between this 3 and 0. So we can say, therefore, the y values are bigger than 0 but less than 3. That's how you describe those y values. Bigger than 0 but less than 3. Between 0 and 3. Right? That's how you describe them. So that would be your answer. Thank you guys for watching this video. Watch out for the next videos. I will post more individual videos for each individual